This is Quadratics Continued and Lesson 7, Graphing Circles and Exponential Functions. So today we're going to start off with the standard form of a circle way down here. But there's been a lot of formulas during this chapter. So please, somewhere on your page, write these 4 formulas down. Make sure you know what they are. And then come back and check and make sure you got them on your own. So here are all the formulas. Be sure that you check and got them all right. Make sure that all the little nuances and all the little signs are where they need to be. And now let's talk about the standard form of a circle. Now the standard form of a circle, the x and the y are both having the h and the k subtracted from it. So note that the h and the k is the center of the circle. R squared is at the end, but just r is the radius. So now let's use this formula and answer some of the following questions. For example number 1, it says write the equation of a circle whose center is 2, 3 and whose radius is 5. So I'm going to just put an h above 2 and put a k above 3 and put an r below 5. So now I'm going to substitute that into our original formula. So we're going to write x minus whatever h is, which is 2, squared plus y minus whatever k is, 3 squared equals, now r squared would be, r is 5, r squared would be 25. So there's the formula of a circle, who has a center of 2, 3 and a radius of 5. Feel free to try the next one, or you can do it with me. So write the equation of a circle whose center is the origin. So I would write 0, 0, and that's my h and my k, and whose radius is 10. So r is equal to 10. R squared would be 100. So we would have, now, if I substitute in, I would have x minus 0, or just x. So I don't need to have parentheses at all. I'm just going to square that. Plus y minus 0 is just y squared equal to, now that r squared is going to be 100. This one looks a little bit different, but both the x and the y are squared. That implies that it's a circle. Always keep that in mind. Go ahead and try number 3. For number 3, I would get h and k, and my radius is equal to the square root of 3. So my r squared would be square root 3 times square root 3, which would give me the square root of 9, which gives me 3. So this would be x. Now minus a negative 6 would give me plus 6 squared plus y plus or minus 0 is just going to be y squared equals 3. Let's try some more. So for number 4, we just go in and we have to find the h and the k to find the center. So it's going to be 5, 2. Remember, the minus comes with the formula. So those, if it's a positive, then that really means it's a negative. All right, so h and k is 5 and 2, and then the radius would be 6. Okay, so remember that 36 is equal to r squared. Therefore, if I square rooted both sides, I would get r is equal to 6. Okay, in the next case, when I have x plus nothing, so that means 0 squared, so that means that's h, and 10 is k. So the center would be 0, comma. Now it's plus 10, which really means negative 10 for my center. My radius is going to be 7. For C, both of them have no number next to them, so the center is at the origin. And the radius is going to be 4. For D, we would have negative 8, comma, negative 2, and we would have 12 as our radius. Now let's go graph these. To graph a circle, all you have to find is the radius in the center. So go ahead and do that for number 5. I found the radius to be 3 and the center to be negative 4, 0. So all we do is we go plot negative 4, 0, and then we go ahead and make the radius by going out 3 and putting points there. And this is the hardest part, is learning how to make a circle so that it looks fairly round. It's not going to be perfect. You're going to get better at it as you do it. Just do the best you can. Go ahead and try 6, 7, and 8. Just recognize that a whole circle is not a function, because if you drew a vertical line through any one of them, it would pass through more than one point. So it's just something to recognize. Let's move on. So let me introduce you to an exponential function. This will be a function, so let's go ahead and begin. We're going to graph y is equal to 3 to the x power. So first of all, let's set up a table so you can see what happens. So this is x. This is going to be our function, y is equal to 3 to the x power. And we're not going to use our calculator right now. We're just going to really explore it. So first of all, let's just see what happens when we start with positive exponents. So we're going to do 3. So we would have 3 to the 3rd power, which would give us 3 times 3 is 9, times 3 more is 27. Now 3 squared would give us just 3 times 3, which is 9. Now we're going to put in for x 1, so that would be 3 to the 1st power, which would be 3. Now we're going to do 0. Remember, anything to the 0 power is 1. So now we're going to do to the negative 1. So remember, 3 to the negative 1 means that I have to take the reciprocal of it. So it's 1/3. And then negative 2, 3 to the negative 2, I take the reciprocal of it and I square it. So that would give me 1/9. Now as we continue, I think you're finding a pattern. Without even doing anything, I can come over here and I would get 1/27. Let's go plot those on our graph. Now 3/27 is really too big, so we won't plot that. Let's start with 2, 9. So that's going to be right up here at the top. And then we're going to do 1, 3. And then we've got 0, 1. And then we've got negative 1, 1/3. So that's really low down here. And then we've got negative 2, 1/9, which is really low. Even lower than that 1/3, and then 1/27. It's getting so low. What's going to happen though is that I don't think it will ever get to the line, because it will always be a fraction that keeps reducing. So what's going to happen is it's going to be a line that never crosses the x-axis but continues to grow exponentially. Now state the y-intercept. Remember that the y-intercept is when x is equal to 0, the y-intercept would be 1. Now I'm just going to label my graph, so y is equal to 3x. And I just want to make note of something that we're going to need in the future, is that what are we doing between 27 and 9? If we look at the pattern here, we're dividing a 3 by everything as it goes down. This is where our future is going to be. So we keep dividing by 3 as it goes down. This is what it's going to look like. This one goes down by, we're just subtracting 1 from both sides. Okay, so this is the pattern when it's exponential. Let's look at the next problem. Now for number 2, let's do this again and let's set up our table. So as we begin, I'm going to always just put 0 in the middle. I'm going to go 1, 2, 3, and then -1, -2, -3. So at this stage, when I put 3 in there, that gives me 1/4 to the 3rd power. So when I multiply 1/4 3 times, I get 1/64. For number 2, 1/4 squared, which gives me 1/16. Continue on your own if you need to, or continue with me, however you feel comfortable. So 1/4 to the first power is again 1/4. And then 1/4 to the 0 power is 1, because anything to the 0 power is 1. Now when we do 1/4 to the negative 1, remember we have to take the reciprocal. That makes it a positive 1, so that's just going to be 4. When we take the reciprocal of -2, that's going to flip it, and then we just square it, and that gives us 16. And then again down here, it's going to give us 4 to the third, which gives us 64. So now go plot that on the graph to the right. As we look at our graph, we can see that again, it will never reach the x-axis. It will always continue to get smaller and smaller and smaller, but will never reach. Now, at this point, we need to solve B because we've already solved for A. And B says, use the graph to determine the approximate value of 1/4 to the negative 0.5. So that's saying when x is equal to negative 0.5, find y. So I look at my graph at negative 0.5, which is about right here, and I go ahead and see where that graph crosses the y, a y-axis or a y coordinate, and it crosses at about 2. So my y is approximately 2. Okay, now what I'd like you to do is I'd like you to type 1/4, use that caret key in your calculator, to the negative 0.5, and you should see that you get the same answer. So go ahead and check. Now we've been graphing these all by hand. I would also like you to know that you can put them in your calculator. The only problem is when you put them in your calculator, all of these answers here will be in decimal form. So when you get those answers in decimal form, you'll graph them just the same way. It'll just be a little bit, they'll look really weird. Yet 1/64 is a very weird number, so you just handle the decimals just the same way you handle the fractions. Now let's make our final conclusion here. Instead of, so I'm going to go from 64 to 16. So what do I do to each one of these to go from 1 to 4? What do? I times it by 4. So this way I times it by 4 to get to 16. I times it by 4 to get to 64. So here I times this by 4 to get to 1 and continue. All right. And this way, we just subtract 1 each time. All right, so the pattern is going to look a little different. Last time we divided each number by a factor. And this case, we multiplied each number or each term by a factor. So for 1 through 4, we have to determine whether the following data display exponential behavior. Remember, what happened for x is we just added or subtracted a 1, whichever way you looked at it. So this is +1 and this is +1. And down here, let's think about what we do. Well, here we're just adding 5. When you add 5. So in this case, this is not being multiplied or divided by a factor. So this graph is not going to be exponential. This one is actually going to be linear, because we're just adding a factor to everything on the top and the bottom for x and for y. Let's take a look at number 2. So on the top one, we're just adding 1 to each one. And then let's check out the next one. Oh, hey, in this case, we're multiplying by 3. We're multiplying by 3, and we're multiplying by 3. So we're multiplying by a factor. Therefore, this one has exponential behavior. Okay, let's look at number 3. So here, instead of going by 1s, we're going by 2s, and that's not a really big deal. So let's see. So this is going to be +2 and +2 and +2. Okay, now let's take a look at the next one. So in this case, we're dividing by 2 to get down. So this one is showing exponential behavior as well because we're multiplying or dividing by a factor. Okay, and let's take a look at number 4. So number 4, each of these keep increasing by +1, but down here they all stay the same. So y will always equal 3. This one is going to be linear as well. And this one is going to be a horizontal line. Thanks for participating in this lesson with me. You're ready to go on and master your skills. All the best.